this tutorial, we'll dive into one of the most fundamental concepts in statistics, the measure of central tendency. Don't worry if that phrase sounds a bit complicated. It's just a fancy way of talking about numbers that helps summarize and describes the middle or average of a group of data. These measures give us a simple illustration of what's typical or most common in a set of numbers. So why is this important? Think about how often we hear the term average in our whole life. For example, when you hear the average test scores in your class, it gives you an idea of how most students perform in a specific quiz or test. Another one is in central tendency. It helps researchers summarize the vast amount of data into single meaningful value. For instance, psychologists might use it for analyzing survey responses or compare treatment outcomes. It can also be used in our government and businesses. They use the average to make decisions about wages, policies, or marketing strategies. So as explained by Graviter and Walno 2020, measures of central tendency are essential for simplifying complex data sets into meaningful and interpretable values. They allow us to understand patterns, make comparison, and of course draw conclusion, all of which are very vital in psychology and many other fields. What are the measures of central tendency? These are the three main types. First is the mean. Mean is the numerical average of all values. Second is median, the middle value when the numbers are arranged in order either ascending order or descending order. The third is the mode, the most frequently occurring value in our dataset. So in this video, we'll cover on how to compute this manually, how to use Microsoft Excel. It is a tool that simplifies calculation. And third is on how to use SPSS, a software used by professionals for advanced statistical analysis. So by the end of this tutorial, you'll know how to compute these measures on paper and using technology, helping you apply these skills to everyday situations and research. Let's get started! Measures of central tendency such as the mean, median, and mode summarizes a set of data by identifying its central point. So these measures can be applied to ungroup data, which has raw scores or individual values, and for group data, values organized into frequency distribution. So, of course, understanding and calculating these measures helps provide insights into data patterns, making them an essential tool in statistics. In order for us to look or to solve for the ungrouped mean, we will have this example. First, we need to do is to arrange it into either ascending or descending order. In this case, we will arrange it into ascending order or from lowest to highest. Now, this would be what our dataset looks like. Now, in order for us to solve for the ungrouped mean, we will use the formula mean is equals to the summation of x over n, where summation of x are the totality of the variables and n is equals to the number of variates. Now, we will input the data into our formula. Mean is equals to the summation of x over n, and if we input all the data, mean is equals to 78 plus 78 plus 79 plus 80 plus 82 plus 82 plus 83 plus 83 and so on up to plus 90 divided by 20, or the number of variates. If we add it all up, we have to make sure that every single variables in our data are included. In this case, we forgot to input the 87 as it appeared twice. So we have to be very careful in inputting our data. Now, after all of that, we will get the summation of 1690. After we got 1690, we will divide it into the number of variates, or 20. So 1690 divided by 20 is 84.5, would be our ungrouped mean. In order to look for the average or the mean in Microsoft Excel, first we need to input our data and then select a cell and put equals to average, open and close parenthesis, and then select the cell that we are looking for the average. After that, we click enter, and then there we have it, the mean or the average of the data set that we are looking for. In the software SPSS, the first thing we need to do in looking for the mean is to input our data in the variable view. First is input the name, and we can name it as the marks or grade. Then the type, make it in numeric form, as the data that we have are in pure numbers. And decimals, we don't need decimals as there are no decimals existing in our data. And label, we will label it as the student's grade in life and works of Rizal. In values, we just have to input all the grades that is included in our data set, which has our first value has 75 to 80. The second value is 81 to 86. The third value is 87 to 92. And since our lowest grade is 75 and the highest grade is 90, that will fit to our data set. There are no missing values, and to alignment, we just have to make it left. To measurements, we just have to make it into scale as we have our numeric form. Then in data view, we just have to paste our data, which are in Excel. You just have to copy it and paste it into the SPSS data view. After doing so, we can now analyze for the mean. First thing we need to do is click Analyze. Under Descriptive Statistics, click Frequencies, and then put the only data into the variable, click Statistics, and click or mark Mean, as that is what we are looking for. Click Continue and OK. Now that we have the result or the output of the SPSS, we can finally have our mean.
Hi everyone, I'm Cheska, and I'm going to show you how to find or solve median for the ungrouped data in manual computation using Excel and using the SPSS software. But first, let's define median. The median is the middle value in a distribution. It is also known as the 50th percentile, and the median tends to stay in the center of the distribution even when there are few extreme scores or when the distribution is very skewed. Now, let's proceed to the manual computation. In manual computation, we were going to arrange our data in highest to lowest or in vice versa. Step 2, if the given data is odd, the middle value is the median. If the given data is even, the average of the two middle scores is the median. In our case, we have a total value of 20 scores of the second year BS Psychology in Life and Works of Rizal. Step 3, if the given data is even, we will use the formula of median is equals to n plus 1 over 2. Since our total value is 20, so 20 plus 1 over 2. 21 20 plus 1 is 21, and over 2 is 10.5. Since we got 10.5, we will find the value of 10th place, which is 85, and the 11th place, 85. Now we will add those numbers. 85 plus 85 is equals to 170. And 170 divided by 2 is equals to 85. Now our median is 85. Now using the Excel for finding the ungrouped median, we will first input the data, and once we input it, we will type median parentheses A1 to A10, then enter. The answer is 85, like what we got on our manual computation. Now let's proceed in SPSS. In SPSS, we have to copy the data from Excel, then paste it in the SPSS. Then let's change it. Let's say scores. Decimal 0. Then left. Scale. Then let's go to analyze. Then descriptive statistics, frequencies, or is here in the variable. Click the statistics, then median, and continue. And click OK. Now we will see the median is 85.
Statistics can be used in everything, hence it can be used in our daily life. It can be used in real life such as planning budgets, finding the best prices for products bought and sold, or even determining the best times to do various daily tasks. For my topic, I will be discussing how to find the mood in a dataset in an ungrouped data. The question here is, what is the significance of finding the mood? If statistics can be used in our daily life, then what is the purpose of finding the mood? Don't worry, we will find that out here in my topic. Okay, so let's first have the manual computation of mode. So, meron tayo ditong dataset consisting of 25 values. 85, 82, 79, 88, 78, 83, 88, 85, 90, 87, 82, 80, 90, 84, 83, 89, 78, 86, 86, 85, 85, 81, 77, 76. So, ang first step na gagawin natin is i-arrange to into an ascending or descending order. So, sa case na ginawa ko is in-arrange ko siya into an ascending order, which is from lowest, yung 75 natin, hanggang sa highest, which is yung 90 natin. After nating ma-arrange yung dataset, titingnan lang natin kung ano yung value na may pinakamarami or nag-occur dun sa set of data. And dito sa example natin, ang nag-occur na ng marami na value is yung 85. Kasi 1, 2, 3, 4, apat siya. Kaya ang mode natin for this set of data is 85. So, proceed naman tayo sa pag-solve ng mode sa Excel. So, kagaya lang ng ginawa natin kanina, in-arrange natin yung dataset into an ascending order. And after that, first thing we have to do is i-input na natin yung formula for mode. So, ang una natin gagawin is click the equal sign and then type mode. Lalabas na dito yung formula natin for mode. So, ang gagamitin natin is mode.single. And then, click lang natin yung values natin from C1 hanggang C25. So, lalabas na siya dito. C1 hanggang C25. And then, huwag natin kakalimutan na ilagay yung closing bracket para mabasa yung formula natin. After malagay yung closing bracket, click enter. And then, lalabas na yung most occurring value sa dataset natin, which is yung 85. Now, mag-proceed naman tayo sa pag-solve ng mode sa SPSS. So, ang una natin gagawin is i-copy and paste lang natin yung dataset natin. So, nakopy ko na siya and paste lang natin siya dito. Ayan, may value na tayo. Then, punta kayo sa variable view. And, para makuha natin yung mode, click analyze, descriptive statistics, frequencies, and ilalagay lang natin yung pag naklik na natin yung frequencies, dito talaga siya unang mapupunta. And then, pag lumabas na tong table na to, click lang natin yung data view natin. And then, pupunta natin sa variables. Then, click natin yung statistics para mahanap natin yung mode natin. And then, click continue. Click OK. Ayan. So, makikita dito na ang mode natin is 25, valid 85, valid na 25 lahat ng values natin and 0 missing. And then, ipapakita rin dito kung ilan yung iba pang values na more than 1. Ngayon, naalam na natin kung paano i-solve ang mode sa dataset. Tandaan natin na hindi lang isang mode ang pwedeng mag-occur sa isang set of data. May mga tawag sa bawat isang mode, and these are, firstly, ang pinakang common na mode, the unimodal, which is a set of data with one mode. The second is bimodal, a set of data with two modes. And lastly is the multimodal, which is the set of data with 4 or more than modes. Now, let's see kung paano ba mag-solve ng set of data with more than one mode. So, meron tayo ditong bagong set of data consisting of 20 values. Sa pag-compute ng mode na more than one in a set of data ay napakadali lang. So, ang uunahin natin is i-arrange lang natin to into an ascending order, and then titingnan natin kung ano yung mga value na nag-o-occur sa dataset na to. So, meron tayong 278, dalawang 82, meron din tayong dalawang 83, meron din tayong dalawang value ng 85, meron din tayong dalawang value ng 86, meron ding 87, 88, and 90. So, dahil may 8 modes tayo, this can be identified as the multimodal, which is a set of data with 4 or more than modes. So, let's try naman na isolve sa Excel yung set of data natin na may more than one mode. So, ginamit ko lang din yung set of data natin kanina sa manual, and ang gagawin natin is select muna tayo ng multiple cells and then click equal sign and then type mode. Dito makikita na natin yung formula for multimodal mode, which is yung mode dot multi or MULT. So click lang natin yon, and then click ulit natin yung values natin. Ayan, nalabas na yan siya dyan. Tapos click yung closing bracket ulit. And para lumabas yung result, kailangan nating i-hold yung control button and shift ng magkasabay, and then click enter. So may lalabas na ganyang formula, and then click enter lang ulit natin. Ayan. So bilangan natin yung lumabas na result. 1, 2, 3, 4, 5, 6, 7, 8. Same lang sa nakuha nating values sa manual. 8 din yung lumabas na mode dito sa Excel. Now, proceed naman tayo sa SPSS. First step is to copy and paste yung dataset natin, which is ito na, yung 1 to 20. And then, punta tayo ng variable view. Click Analyze Descriptive Statistics Frequencies. Eto na yon, yung naka-paste natin kanina. And then, ipunta lang natin siya sa variable. Click Statistics. Click Mode. And Continue. And then, click natin yung OK. Ayan. So, yung process of finding the mode in a dataset with one or more than modes are the same. Pero dito sa multimodal, naka-indicate na meron ng maraming modes na nag-exist sa dataset natin, which is ito. Nakalagay dito na multiple modes exist and the smallest value is shown, which is ito yung pinaka-smallest value natin. And that concludes the process for finding the mode in an ungrouped data. I hope you learned something and will be able to understand statistics, specifically the measures of central tendency sa ungrouped data, with the help of our tutorial video. Thank you for listening, and let's now move on to the group data.
Hi, I am Fons, and today I will talk about the group mean or computing the group mean. So what is the group mean nga ba muna? It is the average of a dataset that has been grouped into intervals. So basically, it is like the simplification of complex datasets. So saan nga ba natin siya nagagamit sa buhay-buhay? Pwede natin siya magamit sa budgeting and finance, on tracking our budget, on health and fitness, sa education, kagaya ng ginagawa natin ngayon, and sa pagko-compute ng mga scores, sa weather tracking pwede rin, and sa customer service. So now, let's move forward sa unang way ng pagkuha ng group mean, which is the manual computation. Good day! So now we will talk about how to compute group mean. So hindi na po ako gumawa ng frequency distribution table mula dun sa data namin kasi hindi naman kailangan yung ibang value doon. So ang kailangan lang po natin dito is frequency and class mark, and mamaya papaliwanag ko po kung ano to. So kung hindi po natin alam kung paano kunin yung class mark, basically kukunin lang natin yung lower and higher value, pag-add natin sila together and divided by 2. So check po natin. So kung 90 plus 92 is equals to 182 divided by 2 is 91. So ganun lang po, tuloy-tuloy lang. 87 plus 89 divided by 2 is 88. So ayun, para makuha po natin tong lahat. So ito pong formula natin, ang formula natin is x bar is equals to summation of x times f over n. So yung x po is yung class mark natin, yung f is yung frequency, and yung n is yung total ng lahat ng frequency. So, ano naman po itong XF? So, ayun, pinag-multiply na po natin yung X and F. So, 3 times 91 is 273. 5 times 88 is 440. 5 times 85 is 425. 3 times 82 is 246. 4 times 79 is 316. So, pag-add lang po natin ito lahat, is it equals to 1,700. So, tuloy po tayo. Magtungo na po tayo dito sa pagko-compute. So, substitute na po natin yung mga value. So, yung summation of XF is equals to 1,700 over N. Yung N po natin is 20. So, ganun lang po siya. I-divide po natin 1,700 divided by 20 is equals to 85. So, basically, ganun lang po mag-compute ng group mean. So, ayun, now we will move forward po kung paano mag-compute ng group mean using yung shortcuts ng Excel. So, ayan. Start po tayo sa pagkuha ng XF. Pinutin po natin yung una. Then, asterisk. Then, yung second value. And enter. Ayan. Tapos, i-drag na lang po natin siya pababa dito para mas mabilis siyang masagutan. Ayan. Tapos, the next one po is para makuha po natin yung summation niya and sum. So, ayun, 1,700. Same lang din po with kanina. So, the next one po, para makuha natin yung divided na summation sa n, type lang po ulit natin equals. Tapos, pinutin natin siya. And this one, tapos yung n and enter. So, ayun po, same lang, 85. So now we're moving forward sa last way ng pagkuha ng group mean, which is using the SPSS. So in-input ko na po ulit yung data na ginamit natin last time. So ayan, dito mo tayo sa variable view. So LI is for the lower limit, LL is for the lower limit, UL is for the upper limit, and F is for the frequency. For the decimals, naka 0 po silang lahat. And ganyan po siya. So unahin natin kunin yung midpoint. So, pipindutin lang po natin is transform, compute variable, and kunin natin yung mid. Small letter lang pala natin. Mid. Ang numeric expression niya is parenthesis, LL, plus UL, parenthesis, tapos over 2. And, i-okay na natin siya. Ayan, lalabas, execute, tapos, and balik tayo dito sa variable, ay sa data view. And lumabas po kagaya lang last time. Gitna nila, 91, 88, 85, 82, and 79. Balik tayo sa variable view, bawasan natin yung decimal niya. Gawin natin 0. Data view. Tapos, next na step is, pinutin natin tong data, weight cases, and ilagay natin na weight cases by frequency. And okay lang natin. Lalabas lang po dyan yan. Weight by F. Balik tayo dito. Then, analyze. Frequencies. Ilagay po natin yung mid. Sa statistics, pinutin lang natin yung mean since yun lang naman yung need natin para sa tutorial na to. And, mag-continue na tayo. Continue and okay. Ayan, lumabas na po dito. So, ayan, the mean is 85. So, kagaya lang nung dun sa manual computation and sa Excel, 85 pa rin po yung lalabas. And that's how you get the group mean using SPSS.
Hello, my name is Sebastian Capio, and in this part of the tutorial, I will be tackling group median. Have you ever wondered how to find the middle of a bunch of numbers when they're organized into neat little groups? That's where the concept of group median comes into play. It's like finding the heartbeat of a set of data that's been neatly sorted into classes or ranges. So no need to stress over individual data points, whether they're about test scores, personality traits, or reactions to a psychological stimulus. Curious to learn how this method works and why it's so important in psychological research? In this tutorial, I will break down what group median is, why it matters, and how it can make sense of seemingly chaotic datasets. Let's dive in. So why is the group median so important? Understanding measures of central tendency like the mean, median, or mode is crucial for summarizing data in a way that helps make sense of the world around us. The median is particularly useful when dealing with skewed data or outliers, as it provides the middle value without being affected by extreme numbers. When data is grouped into classes, as in a frequency distribution, the group median helps find the middle of that dataset by considering the frequency of data points in each group. It allows for accurate analysis without getting bogged down by every single individual data point. The group median is particularly useful when dealing with skewed data, like when some participant scores very high or very low on a test because it gives the middle value unaffected by outliers. In the case of group data, where participants are sorted into categories based on ranges or classes, for example, score intervals, the group median provides a more accurate reflection of where most participants fall within those categories rather than trying to rely on every individual score. For instance, in psychological research, the group median is often used in studies where data needs to be categorized into specific ranges. For example, in research on intelligence, participants might be grouped by IQ scores. For example, 90 to 100, 101 to 110, 111 to 120. And the group median would help determine the most common IQ range within that sample. Similarly, in studies of mental health, researchers might group participants based on symptom severity from mild to moderate to severe, and use the group median to identify the most typical severity level. The group median is a valuable tool for psychologists in both experimental and clinical research, helping them summarize complex data and draw conclusions about typical patterns of behavior. Now to finally start the tutorial, here are the steps in order to get the group median from the measures of central tendency. The group median's primary purpose is to find the median for data that has been grouped into intervals. The former gives an estimate of the central values, and it focuses on the positions of the values within the dataset and gives an accurate central tendency. Now, let's dive into the tutorial.
Step 1. Organize the given dataset into an array of either ascending or descending order. Compute for the range, assume interval, and classes of the data through Sturge's rule and other principles. Now, we will be getting the organized data or the array. Now that we have gotten the array, we will be computing for the range, assume interval, classes, and interval of the data using the Sturge's rule and other principles. Now we will compute for the range. To get the range, we will be subtracting the highest value to the lowest value. The highest value of the data is 90. Subtracted to 78. Now, our range is 12. Now to get our assumed interval or k, we will be using the formula of 1 plus 3.322 logarithmic n. 1 plus 3.322 log, then substitute the n. Our n is 20. Now we will compute. 1 plus 3.322 log log 20 is equals to 5.32. We'll be rounding it off to the nearest whole number, which is 5. Now our k is equal to 5. Now we will be computing for the interval. To get the interval, we will just be dividing the range and the assumed interval. 12 divided by 5 is equal to 2.4. Round up to the nearest whole number and we will get 2. 2 is our interval. Now to get the actual classes, we will be dividing range and interval. 12 divided by 2 is equals to 6. Our classes is 6. So this accomplished step 1 of the procedure to compute for the group median. Step 2. After computing for the range, assumed interval, exact interval, and classes, we will then be categorizing the data into bins or classes in accordance with their intervals. Now we will start from the highest value and work our way down to the lowest value. Let's start with the highest value, which is 90. Now we will be noting our computed interval. Our computed interval is 2. So let us count backwards. 90, 89. That amounts to 2 counts. So our lower limit for 90 for this group is 89. Now we will be just doing the same until we reach the lowest value. 88, 87, 86, 85, 84, 83, 82, 81, 80, and 79. Now as you can see, we didn't reach 78 or the lowest value in the exact classes that was computed or the 6 classes that was computed. Now, according to Sturgis rule, we will be adding another bin in order to complete the sets of data and ensure that there is equal interval for all of the groups. So we'll be putting 78 here. This is our lowest value. And add an extra 77. Now we have completed step 2. Step 3. We will now get the frequency of each classes, then get the sum. The summation of the frequency should equate to the total number of respondents, or n, after which we will divide it into 2 to get the value of n over 2. So 89 to 90, 1, 2, 3. 3. 87 to 88, 1, 2, 3, 4. 85 to 86, 1, 2, 3, 4. 83 to 84, 1, 2. 81 to 82, 3. 81 to 82, 1, 2. 79 to 80, 1, 2. And 77 to 78, 1, 2. Now we will be adding all of the numbers and we should get our n. Our n is 20. 3 plus 4, 7. Plus 4, 11. Plus 3, 14. Plus 2, 16. Plus 2, 18. and plus 2, 20. Now, the tutorial suggests that we will be getting the n over 2. To get n over 2, n 20 divided by 2 is equals to 10. 10 is our n over 2. Step 4. We'll now get the lower limits and put it right next to the frequency column. In order to get the lower limits, it is necessary to take the values of the lower classes and subtract 0.5 to each one in order to gain the exact lower limits. Now, let us begin. 89 minus 0.5 is 88.5. 87 minus 0.5 is 86.5. 85 minus 0.5 is 84.5. 83 minus 0.5 is 82.5. 81 minus 0.5 is 80.5. 79 minus 0.5, 78.5. 77 minus 0.5 is 76.5. Step number 5. We will now be computing for the cumulative frequency. In order to do this, we will copy the n and make it the first value of the CF column. Our n is 20. After this, we will be subtracting it to the first value in the frequency column and continue doing this by subtracting the total number to the corresponding frequencies. Last value must equate with the last value of the frequencies. Let us begin. 20 minus 3, 17. Minus 4 is 13. Minus 4 is 9. Minus 2, minus 3 is 6. Minus 2 is 4. And minus 2 is 2. Now we have gotten our cumulative frequency. And as you can see, the last value of the frequency equates with the last value of the cumulative frequency. Now for our step number 6, we shall find the position of the median and the central values of each column. In order to do this, we shall look for a value in the CF column that is higher than n over 2. So what is the first higher value than 10? Of course, it's 13. Below it is our actual cumulative frequency. 9 is our CF. Now that we have found the row for the group median, we will label it as follows. 84.5 is our representative of the lower limit. 4 is our frequency representative, and the position of the median is predicted to be in this area or in this group, 85 to 86. Now that we have finished labeling each of the central points of each column for the computation, let us now move forward to our last step. Now for our final step in the manual computation for group median, this is the formula that we will be using. Median is equals to lower limit plus parenthesis n divided by 2 minus cumulative frequency over frequency parenthesis multiplied to the interval. Let us substitute the data in order to derive the computation or the exact value of the group median. So our lower limit is 84.5 plus parenthesis. Our n over 2 is 10 and our cumulative frequency is 9. Our frequency on the other hand is 4 and our interval is 2. Now that we have finished substituting the values, we will now be computing for the group median. ND is is equals to 84.5 plus 10 minus 9 is 1 over 4 multiplied to 2 MD, which is 84.5 plus 2. Now from the fraction of 1/4, we will be converting it to its decimal form, which is 0.25. (0.25) multiplied to the value of 2 is 0.5. Now we will be adding the two values, 84.5 and 0.5. 84.5 plus 0.5 is equals to 85. 85 is our group median. Now, that is it for our manual computation for group median. Let us now go over our computation or our formulas in Excel and SPSS to get our group median in those softwares.
Be computing for the group median through the software of MS Excel. So this is a step-by-step procedure of which, and without further ado, let us start. So in order to utilize the function of MS Excel in order to compute for the group median, of course, our step 1 is to input our classes, which is already here. These are the classes that we have computed for in our manual computation beforehand, and of course, the corresponding frequencies. Now, for our second step, we shall be computing for the lower limits. So in order to get the lower limits, we should first look at our lower limits here and subtract 0.5 in order to get the true lower limit. So we will be doing 89 minus 0.5 is of course 88.5, and we will just continue that until we finish up to the bottom. So 88.5, 86.5, 84.5, 82.5, 80.5, 78.5, 76.5. So these are our lower limits. Now we should be looking for our cumulative frequency, but before that, we should do our third step, which is to get the summation of the frequencies in order to ascertain the n, or the number of participants. In order to do that, what we are going to do is equal sign, sum, parenthesis, and then we will drag from here to here, and then close parenthesis, enter. This is our summation, or our n, and in order to compute for the cumulative frequency, we will put our n here because it is the starting value of our cumulative frequency. So here. Now in order to solve for our cumulative frequency and to complete the table, what we're going to do is we're going to subtract our starting value to its corresponding value here, which is 20 minus 3, and do that until we reach the bottom. So 20 minus 3 is equals to 17. 17 minus 4 is equals to 13. 13 minus 4 is equals to 9. 9 minus 3 is equals to 6. 6 minus 2 is equals to 4. And lastly, 4 minus 2 is equals to 2. So in order to know if you are in the right track in solving for the group median in MS Excel, what you're going to look for is the bottom values for frequency and the cumulative frequency. Most of the time, the bottom value here in the frequency and here in the cumulative frequency is equal. So if you see that, then that's a good indication that you're in the right track and you're following the right path in order to get the group median for this specific case. So now that we have finished the table, we can now proceed with listing our values in order to compute for the group median. So first is our n. So what is our n? Our n is the computation or the summation of the frequencies, as it is the total number of participants. So what we're gonna do is put this here, it's 20, n over 2 is just our number of participants divided by 2. So our n divided by 2, we will get 10. 10 is our half of n. And then to get the lower limits, we must first get our cumulative frequency. So our n over 2 is 10. What is the nearest higher value to 10? Of course, it is 13. You see this is 13. So this means that this entire row is where the median is located, and the one that is below it is the actual cumulative frequency. So we will put it here. This is our cumulative frequency. And then for our lower limit, we will be doing what I've just said earlier, sticking to this row as where the median is. So for our lower limits, of course, it will be 84.5. So we'll be putting that there. For our frequency, of course, it's 4, just beside the lower limit. And for our interval, it is 2, because as evident here in our classes, it's equally distributed to have 2 intervals of numbers there. So we will be putting 2, be putting 2 here. Enter. Now that we have completed the list of values needed to compute for the group median, we will now be computing for it using the formula of LL, or the lower limit, plus parentheses n over 2 subtracted to the cumulative frequency, parentheses divided by frequency, parentheses multiplied to interval. So we will be doing that now. So yeah, equal sign, and then the lower limit, plus, and then parentheses, and then will be n2 minus our CF, parentheses, divided by our Fi, and then another parenthesis, asterisk, asterisk, and then multiplied by our interval, then close parenthesis, enter, and this is the result of our computation for the group median utilizing the software of MS Excel. We have gotten the same answer, or the same group median, as we did with our manual computation. And yes, this is how we use the MS Excel in order to determine the group median for grouped data.
Now I will be demonstrating the step-by-step procedure for group median utilizing the software of SPSS. So let us begin. Now for our first step, it is to input the classes and the frequency into the data view. As you can see, we've already done that procedure, so we will move forward to our second step. Our second step is to input the lower limits and upper limits of the classes. So here in the left side, this is the lower limits, while on the right side, these are the upper limits. So we'll just copy it from Excel. There we go. Copy. Then let's go back to SPSS. Here, there we go. Now that we have got our classes, our frequency, lower limits, and upper limits, it is time to edit our variables for our third step. So let's go to variable view. Here, I've already edited the names for the classes and the frequency. Now I will be editing the names for the lower limit and the upper limit. After that, we will check for the type. So for classes, it's string. For frequency, numeric. For lower limit, numeric. And upper limit, numeric. So we assign string to classes because it is the only way that we can assign values that are, like, for example, 89 to 90 in the values section. Since if it is in numeric form, if it is in numeric type, then that would not be possible. So now let's edit the label. There we go. Respondents. Classes. F. Let's just put frequency here. And here, lower limits. And here, upper limits. After that, we will now be editing the values. Okay, so for the classes, our values are as follows: 9 to 90. For interval 1. Next is 87 to 88. Oh, sorry. 7 to 88. So our score in interval 2. Next is 85 to 86. It's our score in interval 3. And lastly, 77 to 78 is our score. Interval 7. Now that we have finished the values for classes, we will now be moving forward to our values for our frequency. Now, since the frequency of the data only consists of 2, 3, and 4, that's the only values that we will be inputting here. So 2, frequency 1, 3, frequency 2, and then 4 is frequency 3. Now we have finished editing the values for lower limit and upper limit. It is not necessary to put values or to group them to values, but as I will explain that later when we will be getting the midpoints. Now, since there are no missing values, we shall not declare for any. Columns is automatic. Alignment is left for nominal, while right for scale. Let's just edit this to scale. There we go. And now that we have finished our variable view, we can look back to our data view, and as you can see, these are the data that is needed to compute for the group median here in SPSS. So now for our fourth step, we will be getting the midpoints. So wait a minute. In order to get the midpoints, we will be first going to transform. After going there, you will be clicking compute the variable, and then what is our target variable? Our first target variable is to get, of course, the midpoint. So we'll be typing here midpoints. Then we will just be typing the numeric expression here in order for SPSS to solve the variables and for us to get our midpoints. So this is how we will be doing it. Parenthesis, select lower limits here, and then plus or upper limit here, then close it up, after which we will be dividing it into 2 in order to get the midpoint. Since now it's all done, double check it and then OK. If you see this word execute, then that means that the computed variable is already in the data view. Let's see here. So you can see these are the midpoints. Our midpoints is 89.5, 87.5, 85.5, 83.5, 81.5, 79.5, and 77.5. Now that we have computed for the midpoints, it's time to move forward to the fifth step, which is the analysis. So in order to get the group median, we will first go to Analyze, Descriptive Statistics, and Frequencies. As you can see, here is our midpoints. You will be selecting this, midpoints, here in our variable list. After which, we'll be going to Statistics and select Median. Since this is a group data and we are looking for the group median, you will just be clicking the values or group midpoints. There we go. Afterwards, we will be checking if there is a check mark here in display frequency tables because we will be needing that. Then OK to generate. There we go. This is our frequency and this is our frequency table, and here is our median. As you can see, our median is in 4 decimals. So if you want to edit that in order to get the whole number, this is what you're gonna do. Just click it. After that, click this, then right click, after which click cell properties, and then lessen the decimal to 0. Okay, so here is our group median computed from SPSS. Thank you.
So in group data, the model class is the class interval with the highest frequency. So the first step that I will do is to organize the data into ascending order. Yeah, I will arrange it into ascending order. So 70 to 82, 83 to 87, and 88 to 92. So now we're gonna create the class intervals. So for simplicity, I will just use intervals of 5. So ito na yun, 78, 82, 83, 87, 88, 92. So now we're gonna count the frequency of each class's interval. So, in the class of 78 to 82, meron siyang frequency na 6. Also, si 83 to 87, then 88 to 92. And since all the class intervals have the same frequency, which is 6, wala siyang clear na model class based sa frequency alone. So, in this case, I will just choose the first class interval, which is the 78 to 82. So, we're gonna apply the formula for this group mode. So, M mode L one minus 2 O divided by 2 times H. Yan. So, after natin malagay yung formula, we're gonna substitute the values, these values into the formula. So, mode is equals to 78 plus 6 minus 0 divided by 2 times 6. 2 times 6 minus 0 and minus 6 times 5. So, mode is equals to 78 plus 6 minus 0 is 6. 6 minus 0 is 6 divided by 2 times 6 is 12. So, 12. Then 6 times 0 is 6. So, minus 6 times 5. Then mode is equals to 78 plus, yan, we're gonna copy the 6. 6, then 12 minus 6 is equals to 6, 10 times 5. So mode is equals to 78 plus, yan, 6 divided by 6 is 1. So times 5. Lastly, mode is equals to 78 plus 1 times 5 is equals to 5. So mode is equals to 83. So, now in Excel naman, to compute this sa Excel, first we just have to create a frequency table for this, which is kanina, diba? Sa ginawa natin sa pag-compute sa kanya manually. So, we're just gonna copy it. We'll just create a frequency table for this, which is this, ito. Yan. After that, we're write the formula, which is this. Yan. Then next, we're gonna compute for the mode of this. So first, we're gonna write down the mode. So mode is equals to 78 plus 6 minus 0 divided by 2 times 6 minus 0 minus 6 then times 5. So mode is equals to 78 plus 6 minus 0 equals 6 minus 2 times 6 is 12, then minus 0 minus 6 equals to 6, then times 5. Then mode is equals to 78 plus 6, then 12 minus 6 is equals to divided by 6 and times 5 ulit. Then mode is equals to 78 plus plus 78 plus 6 divided by 6 is 1. So times 5 siya ulit, times 5 ulit. So mode is equals to 78, then 1 times 5 is equals to 5. So plus 5 siya. Plus 5. Lastly, 78 plus 5 is equals to 83. So ayan, after natin siya i-compute sa Excel, we're just gonna copy it here sa SPSS, sa data view, and then after natin siyang ma-paste, we're gonna go naman here sa variable view, then ayusin natin yung data. Ayan, ayusin natin yung data. Yan, and once na naayos na natin siya, we're gonna click this, analyze, then this, analyze and descriptive statistics, then click natin tong frequencies, select natin siya, then click this statistics, and since ang hinahanap natin is mode, we're gonna click this mode, then continue, and okay. Then, ito na yung result.
These are the salient takeaways from this tutorial about measures of central tendency, the mean, median, and mode in both grouped and ungrouped data. Measures of central tendency, often referred to as the averages, are statistical tools that summarize a set of data by identifying a single value that represents the center of the data distribution. The key measures of which are the mean, the arithmetic average of the dataset providing a balance point, the median, the middle value in an ordered dataset giving the central position unaffected by extreme values, the mode, the most frequently occurring value, indicative of the most common observation. These measures help simplify complex data, enabling research to understand trends and make decisions based on the central tendencies of the data. To further expound, it is dichotomized with two types of data, ungrouped and grouped. Ungrouped data refers to raw individual data points that have not been organized into frequency distributions. In psychological statistics, ungrouped data might consist of scores from a small-scale test or survey responses, allowing for precise analysis of individual variability. On the other hand, grouped data refers to organizing data into intervals or classes utilizing the Sturgis rule. It is often used for larger data sets, and in psychological statistics, group data is essential when analyzing trends in large populations, such as assessing the distributions of IQ scores or reaction times. Understanding whether to use grouped or ungrouped data depends on the size of the dataset and the level of detail required for the analysis. Now to give you a recap on ungrouped mean, median, and mode. Ungrouped mean is calculated by summing all the values and dividing by the total number of observations, or N. It is significant for capturing the average of ungrouped data and is highly sensitive to outliers. Ungrouped median, on the other hand, is identified by ordering the data and finding the central value. It is particularly valuable in psychological research as it reflects the central tendency without being influenced by extreme scores. Next is ungrouped mode. It is determined by identifying the most frequently occurring value, and it is primarily useful for understanding the most common response to behavior. Each measure has distinct strengths, allowing researchers to tailor their analysis to the nature of their dataset and what is being required. Now to give the main takeaways for group mean, median, and mode. Group mean is calculated using midpoints of class intervals and frequencies, offering a precise estimate of the average of large datasets. Its formula is summation multiplied to the frequency divided to the total observations. On the other hand, grouped median is found by determining the class interval that contains the median and applying a formula. The formula is median is equals to lower limit plus half of n subtracted to the cumulative frequency divided to frequency and multiplied to the interval. This measure highlights the central point in the distribution critical for studies with a skewed frequency distribution. Next is grouped mode. It is estimated using the modal class, the class interval with the highest frequency, and it is applied using a specific formula. So the formula goes like the lower boundary of the modal class plus the ratio of the difference between the modal class frequency and its neighboring class frequencies multiplied by the class width. It is identified the most common range in the data, aiding in behavioral trend analysis. For group data, these measures allow researchers to extract central tendencies while accommodating the larger scope and complexity of the dataset. In retrospect, mastering measures of central tendency, whether for group data or ungrouped data, is essential for any psychologist or researcher seeking to make sense of human behavior through the analysis of data. Manual computation, MS Excel, and SPSS are tools that empower us to uncover patterns, compare trends, and communicate findings effectively through the means of the measures of central tendency. Once again, thank you very much for listening, and we hope that we have imparted the necessary knowledge to thrive in an avenue of psychological statistics. Thank you.